Alright, so if we want to find the percentage of women who satisfy this height requirement of at least 70 inches, then we're going to need to use the z-score formula. We have a mean, we have a standard deviation, and we have some x value of 70 inches tall. Alright, so the z-score is going to equal, remember it's x minus mu over sigma, and you round to two places. So our z-score is going to be 70 minus 63.8 divided by 2.6. Alright, so I'm going to pull up a calculator, show you just how easy it is. 70 minus 63.8 divided by 2.6. So I want to round this to two places. So 2.38. That's about 2.38. Now I'm going to have to use my z-score chart, but I have to understand what is the problem asking before I can use my z-score chart correctly. Alright, so let's go back to the problem. Alright, so we want to know what is the percentage of women who satisfy a height requirement of at least 70 inches tall. At least means 70 or more. So we have a z-score for exactly 70. So if we want to know the percentage of women that are greater than or equal to 70 inches tall, then go to your z-score chart. Our z-score was 2.38. So 2.3, and then there's the eighths column. So 0.9913. That value is actually how many women are less than 70 inches tall. Our problem asks greater than. So we want to say 1 minus 0.9913. So 1 minus 0.9913. That will give us a decimal, which then, if we needed to, we could change to a percentage, because it said what percent of women. 1 minus 0.9913. 0.0087. So, or 0.87% if you needed that as a percentage. Alright, so that's what this is showing. The area under the curve is 1, but if we have a z, a point of 2.38, what we're finding is the area to the right, if we want to know greater than 70 inches. Alright, let's see, they got the same thing we did there. Alright, now, if we want to find the actual x value from a known area or a known probability, then we're going to use the z-score formula, but we're going to change it around and solve for x. Alright, so what am I talking about? Let's say that we would have had this problem here, and the problem, instead of giving you how tall, the problem would have given you the mean, the standard deviation, and then said 0.87% of all women can join Tall Clubs International. What is the height that they need to be to join Tall Clubs International? Then we would want to solve or figure out how to get 70 if we have the answer, which was the probability, the mean, and the standard deviation. The way that you do that, so this is finding the x given the probability, the mean, and the standard deviation. The way you do that, our formula, our z-score formula, is z equals x minus mu over sigma. So if I cross multiply here, make that z over 1, then I'll have z times sigma equals x minus mu. And now to solve for x, I just add mu to both sides. So if I flip this around, I'll have x equals mu plus z times sigma. And so if I know, or I can figure out the mean, the z-score, and the standard deviation, then I can find that x value, that exact x value. All right? And so that's what we're doing. That's how we can use areas or probabilities to find x values. You still have to have the mean and the standard deviation. Okay. So you can see here, that's what the book is telling you, or the slide is telling you, that you can find the x by using that formula. All right, so let's look at an example of that. When designing aircraft cabins, what ceiling height will allow 95% of men to stand without bumping their heads? Men's heights are normally distributed with a mean of 69.5 inches and a standard deviation of 2.4 inches. We want to allow 95%. As a decimal, that's what? 0.95. So we want to know what the height needs to be so that 95% of all men won't bump their head whenever they stand in an aircraft cabin. So we need to find the z-score that corresponds to 0.95. Now this isn't using a z-score of 0.95. This is actually going to the table and finding the area that comes closest to 0.95. Alright, so that happens to be this little star right here. You say I have 0.9495, 0.9505. Between those two, this value is used so much because think about it, 95% is a pretty common percentage. So you just follow it and you can see the z-score is 1.645. Alright? So the z on this problem is going to be 1.645. Now let's go back to our formula, how to find x, how to find that value. Was what? X equals mu plus z times sigma. So the height, x, equals mu 69.5 plus z 1.645 times sigma 2.4. Alright, so I'm going to multiply the two numbers first. 1.645 times 2.4, and then I'm going to add 69.5. 73.448. Alright, so if you rounded that to one place, it would be 73.4 inches. Alright, so you see 73.448. Alright, so with normal distributions, are we trying to find a probability? What percentage of women, or what's the chances that? Or are we actually trying to find an x value? What value separates the top 5% from the bottom 95%? So if we're trying to actually find the probability, or the chance of, or the percentage, then that's where we need to find a z-score from some known x value, some known mean, and some known standard deviation. Find the z-score and use that to get the probability or the area. But if you're looking for the actual x value, you know, like I want to know what is a weight that 99% of all men are less than. Well, I would have to know some you know, standard deviations and some means on men's weight, but I could figure out that x value, that weight that 99% of all men are below. Okay? So if you're looking for that X value, that's where you actually have to take the area and go and find the z-score and then plug it in the formula X equals mu plus z times sigma. So let's take a look at, let's try number 16 here. The direction, and this is 16 from the back of the section. The directions tell us that IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. For a randomly selected adult, find the indicated probability or IQ score. Round IQ scores to the nearest whole number. It says draw a graph in each case. So if you need to draw a graph to help you, draw a graph. Alright, if we do number 16, find the probability that a randomly selected adult has an IQ between 110 and 120, referred to as bright normal. That's probably where I would fall, if I had to guess. I don't know. Never taken one of those. Alright, so in this problem, we were told in the directions that the mean is 100, the standard deviation is 15. We want to look between two values. We want to look between an IQ score of 110 and an IQ score of 120. And we want to know what percentage would fall there. If you randomly selected a person, what's the probability, I guess, that their IQ score would be between 110 and 120. Alright. So we're going to need to find a z-score for both of these since we're doing between. You know, if it would have said less than, then we'd only have one z-score. If it would have said greater than, we'd only have one z-score. But we want to know between two. So I have to find a z-score for both of these. So X minus mu over sigma. Do the same thing here, except the X is 120. X minus mu over sigma. So find the z-score for both of those. Remember, we round a z-score to two places. So this is z equals 0.67 for the first one. And z equals 1.33 for the second one. Alright, and so if we want to know the probability between these two, we need to find the area in the table for the larger z-score and then subtract the area in the table for the smaller z-score. That will give us the probability that a randomly selected person has an IQ score between 110 and 120. Alright, so we need to go back to our table. So my larger z-score was 1.33. Alright, 1.33. So 0.9082. .9082. That's the probability that, I mean, I could make up 1,000 different problems, but if I wanted to know the probability that a randomly selected person had an IQ score less than 120, that would be it. 90.82% of the population supposedly has a IQ score less than 120. That wasn't what I was asked, but I want to know the probability that a randomly selected person would have an IQ between 110 and 120. So there's 120. That's the probability for 120. Now the probability for 110. Need to look up 0.67. 0.7486. Now, if I want to know the probability between, I'm going to say 0.9 0.082 minus 0.7486. All right. Punching that in the calculator, and I get 0.1596. So that's about 0.16, or about a 16% chance. Okay. All right, so let's look at let's find us another problem here. See if there's a, yeah. All right, let's look at number 20. That looks kind of interesting. Mensa. Mensa International calls itself the Internationally High IQ Society, and it has more than 100,000 members. Mensa states that candidates for membership of Mensa must achieve a score at or above the 98th percentile on a standard test of intelligence, a score that is greater than that achieved by 98% of the general public taking test. Find the 98th percentile for the population of the Wilshire IQ scores. This is the lowest score meeting the requirement for the Mensa membership. All right, so we want to actually find the X value. We're going to use the same mean and standard deviation. This problem still falls under that set of problems. So mean is still 100, standard deviation is still 15. It's just we're looking at an area, or the probability, 0.98. All right, so let's go to our table. And we're not looking up the z-score 0.98. We want to know what z-score corresponds to an area of 0.98. So we need to get as close to 0.98 as possible. So you see I have 0.9798 and 0.9703. Which one of those is closer to 0.98? The first one, right? The first one is 2 10,000ths off. The next one is 3 10,000ths off. So we want the z-score that corresponds to this area. So that's 2.06. 2.06, I believe. Let me double check. No, that was a 0, so that's 1, 2, 3, 4, 5. So 2.05. Is that right? All right. So that's our z-score, 2.05. So we can find the X value that is just a little over 2 standard deviations away from the mean. X equals mu plus z times sigma. So X equals 100 plus 2.05 times 15. All right, and so if you do that, you get X equals 130.75, and if that's the actual IQ score, we need to round that what? Up. So it'd be an IQ score of 131. That would be the smallest IQ score you could have to get into Mensa.